In this video, we're going to talk about functions. So I'm going to go ahead and give you the definition of a function. I'm going to change it a little bit from how the book words it, but they're both basically the same definition. So functions, and most students have seen functions at some point or has this idea of an input and output relationship. So a function matches an input value with exactly one output value. That's a sad A. Let me fix it. Capital A. There we go. The most important phrase in this definition is exactly one. That's the most important phrase. And the reason is if it goes to more than one, if our input matches to more than one value, that makes it not a function. Real quick, I wanted to note that we do use another or other terminology when we talk about input and output values. That's independent versus dependent. So inputs are thought of as the independent variables, and then outputs are thought of as the dependent variables. And it makes sense because the output actually depends upon what input you are looking at. So it does make sense, this terminology of independent and dependent. Typically, though, they use that when they're talking about actual variables. And in this case, we're kind of being general right now. Okay, let's look at an example and see if we can identify these real world examples, whether or not they'd be functions. So is your height a function of your age? So in this case, we're going to go ahead and assume that height is the dependent variable. And age is the independent variable. Because height is depending upon the age, the way they've worded that. Is your height a function of age? Okay, which really means that height is our output, age is the input. That's the big important bottom line there. Okay, so that means then I'm looking at an age and I would see if I only map to one height. So let's take myself, for example. I'm not 30 years old, but let's pretend back when I was 30 years old, or let's be really specific. On my 30th birthday, okay, I happened to be 5'4". So that's 64 inches. So when I was 30 years old, I was 64 inches. So that's the pairing on my 30th birthday. And I'm being that specific because we know that kids grow, right, really fast. So like, let's say, I'm looking at when I was exactly 5, like I turned 5 years old that day. All right. And let's say on that day, I happen to be, I'm going to make this up based on some information I was looking at. Let's say I happen to be about 42 inches. Okay. But I go to the doctor later on in the year, maybe 9 months down the road, which would be 5.75 is the age. And in that case, say I grew half an inch, 42 and a half. So by being specific to like a day, it's very rare you're going to take measurements, first of all, twice a day. But second of all, to see that type of difference would probably be too hard for us to see. We can use decimals by this as making sense. But the point being that we're never going to have two heights talking about these specific times in life, ages that we are. We're not going to have two heights in that same moment. Okay. And therefore, yes, this is a function. It works. For every input, there's only one output. Visually, I just want to kind of address that. It's kind of a fun graph. Well, fun at the beginning, boring at the end when you're talking about somebody's life, right? And their heights. The idea is, okay, we come into this world very tiny. And then we grow, 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 grow. And then maybe there's like a little growth spurt. And then we kind of taper off. And for many years, we're this very boring height. And then towards the end of our life here, let me extend this out. I'm going to pretend I have a very long life here. Towards the end of our life, we do start to shrink a little. I don't want to count how many dots I just did there, but that's the idea. And that would mean that this does represent a function, because every single input value that I look at, like let's look at this one. Here, sorry, it's right there. Every single input value only gets matched with one output value. So these are the inputs. And over here, these are the outputs. Most people associate inputs to what most people call the x-axis or horizontal axis. Outputs typically think of the y-axis or the vertical axis. A lot of books are using horizontal and vertical more instead of trying to give them the labels x and y. They're trying to get people used to thinking of it as other variables. Okay, let's look at the reverse. Is age a function of height? So now we're swapping it. In this scenario, age is the dependent one. So it's the output here. I'm going to label it output instead this time. And height happens to be the input. So if I say, okay, 64 inches, that maps to a lot of different ages, right? I think I maybe hit that height when I was 16. Okay. But it also works with, 17 and 18 and 19 and 20 and so forth, right? It just keeps mapping to the same value over and over again for years and years and years until I finally start shrinking. All right. So this does not work. It is not a function. And I kind of wanted to discuss the visual of the first example because I wanted to talk about the vertical line test. Vertical line test, a lot of people have seen this before, is a way of testing whether or not something is a function. So if you draw a vertical line through the graph of equation and it touches only once, then it's a function. I think I did word this differently too than how the book does it. I think a lot of people like to do it the opposite way. If it touches more than once, it's not a function. Same idea. Okay. Okay, so here, real quick, for the example I have above, that makes sense. If I were to connect all these dots, make it continuous. Anywhere I draw a vertical line, it's only, once in any location, even over here, right? Only going to touch it once. So that is a function. Okay, moving on. Box that. Let's use this information to look at tables. So in this case, we're interested to make sure that it gets paired with only one output. And in part A, that is definitely the case. 2 goes to 3, 6 goes to 10, 13 goes to 10. Okay, yeah, those two go to the same value, but that's not a problem because each input, and I'm assuming, of course, that these are the inputs, the top ones, right, are the input. And the bottom was the output. Here, might as well write it down. Then that works because every input is going to its own output, even if they're matching. All right, so just like above with the heights, right? You can have multiple ages go to the same height. That's a function. But here we have a problem in part B because 6 goes to 10 and 14, and that's a problem. 6, that input got matched with 2 different outputs. So that's not a function. And what that means then is I'm kind of concerned then with seeing in a table that the inputs aren't repeating. And as long as the inputs aren't repeating, I don't really care what's going on with the outputs, that works as a function. So part C here, that's a function, since every input is getting matched to one output. Okay, so looking down here, we can use our vertical line test for these, and that's only going to hit once, no matter where I draw it. It's going to put vertical. That's weird. Function. That one works. Okay, here. Boop, hit twice. And all you needed is one place where it hits twice. You don't have to draw it a bunch of times. If it hits twice, it's no longer a function, even if it only happens in one position. We'll actually see some opportunities of seeing examples where that's a problem. Okay, where there's one point where it's a problem. Okay, boop, boop, boop. All right, it works. Function. I usually draw a few. Okay, so my only real concern with this one is kind of like making sure it's a little slanted, and it is. And the reason is, you know, I want to draw a vertical line and it only hit once. And I think that works in this one. I believe that's the spirit of this. So function. All right, let's look at this one. No, not a function. Oops, sorry, I bumped the screen while I drew and it got mad. Not a function. It hit twice. All right, now there is a rule that worries about the outputs repeating in like a table. Okay, that's the one-to-one rule. All right, so a one-to-one function, I want to note that it actually says function, so it's got to be a function, but also make sure that each input corresponds to exactly one output and every output at exactly one input. So it goes the opposite direction. So a one-to-one function is a function, so it's going to be a function. Each input goes with only that, or I should say where every output corresponds to exactly one input. So it's this kind of reverse direction. So it is a function. So it's going to pass the vertical line test. One input to one output, only one output, and then same backwards. We won't see repeating. Okay, so here, let's go back to those tables. So now the first table is a problem. This one is not one-to-one. And oh, by the way, there's like a nifty little shorthand of 1-1. A lot of math people use that shorthand to say one-to-one instead of writing it out every time. So not one-to-one because this out, oops. I thought the highlighter was highlighted. Got to give it a second. This output matched with two different inputs. 10 came from two different inputs, and that's a problem for one-to-one. Okay, we already know this one's not a function, okay, but it is one-to-one. Okay, so that's not one-to-one, but it was a function here. Function, not one-to-one. One-to-one, but not a function. I think this was my highlighter from earlier that I thought I did. Okay, and then here, this one is one-to-one and a function. It's both. We don't have any repeating in either the input or the output. So we're good on that one. So there we go. In this case, that's how we can look at one-to-one versus functions. Okay, one-to-one basically leads us right into the horizontal line test. So the horizontal line test, just like the vertical line test, is if a horizontal line is drawn through, wow, that's not how you spell through the graph of an equation, and it touches only once, then it is one-to-one. It is possible to talk about things as being one-to-one, separate from them being functions. Okay, that is possible. So which of the graphs, actually, I think this is supposed to say which of the graphs are one-to-one here. I'll make sure to fix that on the notes. Are one-to-one. All right. So horizontal line test this time. Boom, that one fails. So it's not one-to-one. That one fails too. It failed both vertical line test and horizontal line test. This one fails. Boom, there it hit 3 times. Okay, not one-to-one. Ah, this one doesn't fail. All right, this one finally got our first one-to-one. And oh, this one doesn't fail either. So this one's one-to-one also. So this one is the only function or only graph that's both a function and one-to-one. That's this one right here. It's both a function and one-to-one. So this is the only one that hits that double, okay, horizontal and vertical line test. But that's it. Everything else doesn't work. And that's it. So I'm going to save function notation for the next video.